So for number 1, we're finding the domain using interval notation, and we'll start by getting the numerator, which is the square root of x plus 5, and setting it to greater than or equal to 0, because you cannot have a negative in the radical, and you end up with x is greater than or equal to negative 5. And you take the denominator, which is x minus 9, and set it to 0, because you cannot have division by 0, and you get x equals 9. So x cannot equal 9 on the graph. And so from there, using interval notation, you know that the x values have to be greater than negative 5, and they cannot be 9. So using a bracket including negative 5 to 9, and then 9 to infinity. And that's it. Alright, so for number 2, we're finding the range using interval notation. And you basically take 7 minus x squared and plug that into a calculator or some kind of graphing tool, and you get this graph here. And you can see that the y values go from negative infinity all the way to 7. Stop there. So using interval notation, you say negative infinity to 7 with a bracket because it's including 7. That's it. Alright, so for number 3, we're finding the vertical and horizontal asymptote using limits, and the screen's a little squished here, so we'll have to make do, but we have x squared over x squared minus 25, and this is a graph you'll get when you plug that in. Again, you're probably going to need a calculator or a graphing tool for this. And for the horizontal asymptotes, you can see over here, oh, just kidding, it's not working. There we go. So we got limit of f of x equals 1 as x approaches negative infinity, which you can see here. F of x, y values approach 1 as x approaches negative infinity. And we have right here limit f of x approaches 1 as x approaches positive infinity, which you can see here. This approaches 1 as x goes to positive infinity. And for vertical asymptotes, we have two. We have negative 5 and positive 5, and one way to find that out is by factoring x squared minus 25, and you set those to 0, and you find that you have positive and negative 5. Or you can simply just look at the graph and see. And so as x approaches negative 5 from the negative side, so negative 5 from this direction, y, or limit of f of x, approaches infinity. And as you approach negative 5 from this direction, limit f of x approaches negative infinity, which is right here. That's how you would write that out. And for positive 5, as you approach from this negative direction, limit of f of x approaches negative infinity. See, it's going down. And as you approach from the positive direction, limit of f of x approaches positive infinity. And that's a wrap for that. So for number 4, we are identifying where the function is increasing and decreasing using interval notation. And if you plug in x squared divided by x squared minus 9, this is the graph you'll get, and the arrows kind of cover it up, but you can see for the most part. And we have increasing from negative infinity to negative 3, and negative 3 to 0. Yeah, so we have increasing negative infinity to negative 3, and negative 3 to 0. Now, negative 3 is a vertical asymptote, so these would not be included with brackets. However, 0 is included, as you can see the line goes through 0, and so you'd finish with a bracket on 0, and it decreases from 0 with a bracket, 0 to positive 3, and positive 3 to infinity. Again, you can see 3 is another vertical asymptote. Similar to the previous problem, if you simplify this here, you'd have x plus 3 times x minus 3. So you can see the zeros on the graph, and yeah, that's that. So for number 5, we're finding the inverse of g of x, and I'm stating the inherited domain. However, I don't think I'm going to include that. Alright, sorry, scratch that last part. So we're finding the inverse of g of x, as you can see here. And g of x is x minus 3 over x plus 1. And so what we did is I switched x and y, so it's x equals y minus 3 over y plus 1. And then I went right into multiplying both sides by y plus 1, because I want to try and separate that from itself on the side. And by doing that, I got xy plus x, because I distributed these two, equals y minus 3. And from there, I added 3 to both sides and subtracted xy from both sides, switched places. So I have x plus 3 equals y minus xy. And over here, you see I then factored out a y from here, because it's y minus xy. So that's y times 1 minus x, and then I divided 1 minus x on from each side to get the final inverse, which is x plus 3 over 1 minus x. Alright, so for number 6, we're writing this expression here as a single logarithm. And to start out, you'll notice that for log x minus 2 log 3, you can utilize the quotient rule, where subtracting it is also equivalent to dividing it. So we bring the equation to log x to the 4th power over 3 squared plus log y over 7, and that is utilizing the power rule. We reversed it, 7 log y, you bring 7 as the exponent. So from here, you take log x to the 4th power over 3 squared plus log y to the 7th power, and you implement the product rule, where adding logs is the same as multiplying them, and that takes you to your final answer, log x to the 4th power times y to the 7th power over 9. And yeah. Alrighty, so for number 7, we are evaluating this logarithmic expression, and to do so, we're going to manipulate its current form into b to the y power equals x, which is, as you can see, is just a different form of this. And so to start, we take the base, which is 7, and as you can see here, b, and set it equal to the x, which is 1 over the 11th root of 56. I'm sorry if I didn't say that correctly. And so from there, we're trying to figure out 7 times what equals x, which is this right here. And so we're going to try and simplify it into more relative terms. So we take 56, the 11th root of 56, and change it to 56 times 1 over 11 to the 1 over 11th power, excuse me. And then from there, we take 56 and put it into a multiple of 7. So 7 to the 8th power, which is the same as 56. And then you dish it out over here. So 8 times 1, common math, so 7 to the 8th over 11th power. And then you change the sign, so whatever the rhyme is, flip it over here, so it's 7 to the negative 8th over 11th power. So the rhyme is change the sign and cross the line, which is what we do here, and that leaves us with 7 to the what power equals 7 to the negative 8th over 11th power. And that's where we use the 1-to-1 rule, where if these base numbers are the same, which is 7, so they're both 7, then this exponent is the same, or equal to each other. So therefore the mystery power is negative 8 to 11th. So 7 to that power equals 1 over the 11th root of 56.